Hello guys, welcome back again to another video regarding your chapter 2, that's a relation and function. In this video we shall study about exercise 2.3 and some miscellaneous question. So let us start with the exercise. So before we start exercise, there's first topic, which is nothing more than your function. So the definition is given to be: let A and B be two non-empty sets. Then a function f from A to B is called a function if every element in A has a unique image in B, and we write f such that A tends to B. This sign is nothing more than your tends to. Now if we can look over here, there is a particular word known as unique. What do you mean by unique? Is nothing more than containing one and only one. Okay, so in short, your set A should have one and only one image in B. Now, if you didn't understand the definition, so let us just illustrate it with a beautiful diagram, I would say. So, let me just say one diagram. One, two. By diagram, it means I'm going to illustrate it with an arrow diagram. So, let me consider this one to be A, B. Your set A wouldn't be nothing more than your pre-image, and your set B will be your image. Okay, so inside it, let me just give number 1, 2, 3, 4, and B, A, B, C, D. Now, this line, if every element in A has a unique image in B, it means this one, like this. If you can see, 1 got exactly one pre-image, or one image, 2 got again exactly one image, 3 got exactly one image, 4 got exactly one image. So that's nothing more than your function. Okay, again similarly, if I draw another one and say A, B, 1, 2, 3, 4, A, B, C, D, and I say this one. So this is your pre-image, and that's your image. This one is not a function. Why? Because 1 got 2 image, which doesn't match with the definition for a function. So that's not a function. Okay, let me draw one more diagram. This diagram, the answer, I want you to write down on a comment section whether this is a function or not. Okay, so let me draw the diagram. So tell me whether this is a function or not. Okay, the latter part of the definition is given to be: if a set A comma B belongs to F, we write f of A is equal to B. Now this one, in your previous exercise we have studied that the first element is nothing more than your domain, and next one is your range. And also, according to the definition for your function, this would be your answer. That's f of A is equal to your B. Remember, your A is nothing more than your domain and B is nothing more than your range. So here B is called the image of A under F, that's nothing more than function, and A is called the pre-image of B, which we already did over here also, right? So again, it's given that if F such that A tends to B, then domain would be nothing more than your set A, and range will be a subset of your set B. So that's all about your definition of your function. Under function also comes different kind of function, like your identity function, constant function, polynomial function. I'm gonna do just the function which are important. Like the first one, nothing more than your real function. The definition is given to be: a function f such that A tends to B is called a real valued function if A and B are both subset of R. Remember, the set A and B should be a subset of your real value, that's your R. Okay, so next one is nothing more than the modulus function. The definition is given to be: if f such that R tends to R. Your R tends to R means both are nothing more than your real number, such that your f of x is equal to modulus of x. For each x belongs to your R, then f of x is equal to modulus of x equal to x when x greater than or equal to 0 minus x when x less than 0. As we know that modulus is always greater than what? 0 for all x. So that's nothing more than your definition for your modulus function. Okay, so over here, domain of f, domain means this is the one. Domain of f would be your all real value, and your range of f would be nothing but, now if you can see, range of f, can a modulus be negative? No, right? So your answer of this one is given that greater than 0, so it will be nothing more than set of non-negative real number. So that's your modulus function. Okay, the third one that comes under function is nothing more than your Signum function. So the definition is given to be the function f such that r tends to r, both are real number, that is given to be f of x is equal to 1 if x greater than 0, 0 if x is equal to 0, minus 1 if x less than 0 is called the Signum function. This whole thing is nothing more than your Signum function. Okay, so over here also domain of f, the domain is nothing more than from real number, so it will be nothing more than your real number, and range, your range of f. So what is the answer I'm getting? 1, 0 and minus 1. So range would be nothing more than 1, minus 1, 0, 1. So that's about your Signum function. Then comes the very important topic, nothing more than your greatest integer function. The definition is given to be the function f such that r tends to r, defined by f of x is equal to your greatest integer function is defined in this manner. Okay, the bracket x belongs to r, assumes the value of the greatest integer less than or equal to x. Now some of you might not have understand the definition. Let me just illustrate with an example. So such that if I say 2.01 is given under the bracket, okay, so it's given that this bracket should be less than or equal to x. It's given in a decimal point, the answer should always come out with a non-decimal point. So 2.01 is given to be less than or equal to x, so the answer will be 2. Similarly, your 2.9, which is a little bit equal to 3, but the answer is given to be less than or equal to x, right? So answer will again be 2. Similarly, 2.99, the answer would be again 2. And lastly, if I say another one, minus 1.3. Minus 1.3, closer to minus 1.3, that's not in decimal point, and which is less than minus 1.3 is nothing more than minus 2. Similarly, your 3, see, your 3 doesn't have any decimal point over here, right? So answer will be your 3, and so on. So that's all about your greatest integer function. Okay, let us start the exercise. Exercise 2.3. Question number 1 is given that which of the following relations are a function? Give reason. If it is a function, determine its domain and range. Question number 1, I want you to try by yourself. Question number 1, 2 is given to be 2, 1, 4, 2, 6, 3, 8, 4, 10, 5, 12, 6, 14, 7. Now, I would say this is a function. Why? Because every image got a unique pre-image. See, 2, 1, 4, 2, 6, 3, 8, 4, 10, 5, 12, 6, 14, 7. It doesn't match. Yes or no? So, I would say that yes, it is a function. So, if it's a function, then I have to determine its domain range. So tell me what will be domain. Your domain will be the first element. So that's nothing more than 2, 4, 6, 8, 10, 12, 14. And similarly, your range. Your range means the second element. That's nothing more than 1, 2, 3, 4, 5, 6, 7. Okay, now let's do question number 3. 1, 3. So it's given to be 1, 3, 1, 5, 2, 5. For question number 3, I would say it's not a function, because according to the definition of function, an image should have a unique pre-image, right? Over here, the image 1 got 3, and again image 1 got 5. So it's not unique. Yes or no? So it will be no, it is not a function. Okay, now I have left question number 1 for you. Please do try. Alright, question number 2 is given to be find the domain and range of the following real function. So 2 is given to be f of x is equal to root over of 9 minus x squared. Okay, by root, one small term comes under that. Root over 9, what's the answer? Everybody knows the answer is either plus or minus 3, right? Similarly, root over 4, what's the answer? It will be plus or minus 2. But if I happen to ask you root over minus 9 or root over of minus 4, do you have any answer? No, right? Why? Because the answer doesn't exist, as a root over cannot be negative. Okay, so don't forget that a root over cannot be negative. And similarly, 0 by 1 was the answer, 0, but 1 by 0 is how much? Undefined. So these are some small tips, don't forget it. So let's go with the question. Okay, the question is given to be how to find the domain and range of this one. Now if we can look over here, if I have to draw this one in a bracket, your x would be your domain and 9 minus x squared is your range. That's the definition of your function. Right. So same thing over here. So in short, this is your domain and this is your range. So a domain I have to find, and this is your range. So I can say that here f of x is defined if and only if 9 minus x squared is greater than or equal to 0. Now why did I write this one is because 9 minus x squared comes under what? Root over. And root over cannot be negative. So it can be either be 0 or greater than 0. Okay, our main concern is to find the domain, don't forget it. So the next term I can say minus x squared minus 9. Now there's a little bit tricky part over here. I got both minus and minus, means I can cut minus and minus. So next term will be x squared 9. So if you are changing the sign, even this sign will change. Your greater than sign will be your less than. Okay, so x squared I can say x squared less than equal, sorry, x less than equal to plus or minus 3. I guess you're clear until there. So that is minus 3 less than equal to x less than equal to 3. That's the only simple term I can come over with x. So I can say that hence your domain of f of x is nothing more than how much? Minus 3 comma 3. Look at the bracket. Okay, why I'm giving this bracket is because there is an equal to sign, which you have already done in your exercise 1. Okay, now let me come to your range. Your range happens to be this one, so I'm gonna assume this one to be your y. So let y is equal to root over of 9 minus x squared. Okay, I'm taking y is equal to root over of 9 minus x squared, but our main agenda is to find the value of x, because in the question there is no y, only x is given. Okay, so that will be, I can say that y squared is equal to 9 minus x squared. So x squared is equal to 9 minus y squared. X is equal to root over of 9 minus y squared, which again I can say that which exists if and only if your 9 minus y squared is greater than or equal to 0, because root over cannot be negative. So it will be minus y squared greater than or equal to minus 9. Again same thing, just like previous one, I can cancel minus and minus. So whenever you're changing the sign, even this sign will change. So y squared less than or equal to 9. So y is less than or equal to plus or minus 3. So that's, I can say that is y, sorry, that is minus 3 less than or equal to y less than or equal to 3. So that's all about your y. But y is equal to root over of 9 minus x squared, which is given over here. Okay, and I got the value for y to be how much? This one. So I can say that, but y is equal to root over of 9 minus x squared, which is non-negative. So that is, your non-negative means this one would change into what? It will be 0 less than equal to y less than equal to 3, because less than 0 are all negative term, and it's given that y is equal to root over 9 minus x squared, which is non-negative. Yes or no? So hence I can say that is y belongs to 0, 3. So hence range of f of x is nothing more than 0, 3. This question is tricky, okay? So I want you to pause the video whenever you like, check each and every details. I hope you'll be clear. Okay, question number 3 is given that a function f is defined by f of x is equal to 2x minus 5. Write down the values of number 1 f of 0, number 2 f of 7, and number 3 f of minus 3. This one is very easy, I would say. It's given to be this one. So let me do number 1. Your f of 0 would be how much? 2 into 0 minus 5. So which is minus 5. I just have to put the value of x. See, it's 0, so let's put it over there. Similarly, number 2 is given that f of 7. So it will be 2 into 7 minus 5. So that's 14 minus 5, which happens to be 9. Similarly, number 3 is given that f of minus 3 would be 2 into minus 3 minus 5 minus 6 minus 5 minus 11. So that's all about your question number 3. Okay, question number 5 is given that find the range of the given function. So number 1 is given to be f of x is equal to 2 minus 3x. X belongs to R, x is greater than 0. Okay, now over here, the question didn't ask about the domain. The question says find the range. Range means this is the one. Yes or no? So let me try to do it in a different manner. So as you can look over there in the question, it's given x belongs to R and x is greater than 0. Okay, so I can say that as x belongs to R and x greater than 0. I'm gonna take the help of this one in order to get the answer of that. So x greater than 0 already done. Next step I can say multiplying minus 3 on both sides. So if I multiply minus 3 on both sides, I'll get this answer to be minus 3x greater than minus 3 into 0. You can do it in this manner. Alright, see where I'm tending to this one to go over in this manner. So I got minus 3x greater than minus 3, 0. So I got both minus minus. So whenever changing the sign, even this sign will change. So next step will be minus 3x less than 0. After minus 3x, what comes? 2. So it will be adding 2 on both sides. So if I add 2 on both sides, I'll get here 2 minus 3x greater than 2 plus 0. So that is 2 minus 3x less than 2. So 2 minus 3x is nothing more than what? Your f of x. Yes or no? So I can say f of x less than 2. I hope you're clear. So I can, therefore, your range of f of x would be, range of x would be what? Nothing more than less than 2. It means minus infinity till 2. Okay, remember there's negative sign over here. Minus infinity till 2. Okay, I'll write it nicely. Minus infinity till 2. So that's your 5.1. Okay, let us similarly do 5.2. Your 5.2 is given to be your f of x is equal to x squared plus 2. X is a real number. Alright, this now is given that x is a real number, so I can say as x is a real number, then can I say x square greater than or equal to 0? Why? Because the square cannot be negative. It can either be 0 or greater than 0. And why I'm doing that? Because I'm trying to get in this manner. So I already got x squared. Next, what I can do, adding 2 on both sides. So if I add 2 on both sides, what will we get? 2 plus x squared greater than or equal to 2 plus 0. So that will be 2 plus x squared greater than or equal to 2. That is your f of x greater than or equal to 2. So therefore range of your f of x greater than or equal to 2, it means now there is an equal to sign. So 2 and goes beyond, right, till infinity. So that's all about your question number 5 too. Alright, let us do some question based on your miscellaneous exercise. Question number 4 is given that find the domain and range of the real function f defined by f of x is equal to root over of x minus 1. This is the same thing as question number 2 of your exercise 2.3. So let's do. So it's given root over. Okay, so I can say that clearly your f of x is defined if and only if your x minus 1 is greater than or equal to 0. Yes or no? So x greater than or equal to 1. So therefore your domain of f of x would be x greater than or equal to 1, means 1 till infinity, and it goes beyond. That's why they say round bracket. Alright, so again, now let us try to find the range. Range means that's the 1. So again, let y is equal to root over of x minus 1. So if I square on both sides, it will be y squared is equal to x minus 1. So I can say that your x minus 1 is equal to your y squared. So which would be x is equal to y squared plus 1. So no matter what I take the value of y, I'll get the answer of x to be in what? A real valued function or not. So I can say that clearly for every real value of y, x is real. So hence range of f of x is nothing more than your r, real value. So that's all about your question number 4. Question number 6 is given to be let f is equal to x comma x squared divided by 1 plus x squared. X belongs to r. So I have to determine the range of r. I have to get the range. Okay, so if you look over here the question, this one is nothing more than, I can say f of x is equal to your x squared divided by 1 plus x squared. That's the definition for your function. Yes or no? That means I have to find this one. That's your range. So let us do in a similar manner. So let y is equal to x squared divided by 1 plus x squared. Okay, you can pause the video whenever you like, okay? Just go through it nicely. So y is equal to x squared divided by 1 plus x squared. Okay, the next thing I'm gonna interchange, so that will be 1 by y is equal to 1 plus x squared divided by x squared. That means I change the numerator and denominator, so this will come up. Next term, 1 by y is equal to 1 by x squared plus x squared by x squared. What I did, I break them apart. I guess you're clear. So it will be 1 by y is equal to 1 by x squared plus 1. I hope you're clear till there. So now I'm going to bring this one over here. Okay, so there will be 1 by y minus 1 is equal to 1 by x squared. So in another word, I can say that 1 by x squared is equal to 1 minus y divided by y, from here to here. I hope you're clear. So now again I'm gonna bring this denominator up, so this will come up. So there will be x squared is equal to y divided by 1 minus y. So in x would be how much? Plus or minus root over of y divided by 1 minus y. I hope you're clear. Alright, then I can say that now x exists whenever 1 minus y not equal to 0, because if this one happens to be 0, then the answer will be undefined. So that will be minus y not equal to minus 1, so y not equal to 1. Now I got to answer plus or minus root over of y divided by 1 minus y squared. So it will be either your y divided by 1 minus y would be greater than or equal to 0. That is, I can say that y greater than or equal to 0, or 1 minus y greater than 0. See, I've got here an equal to sign, but there is no equal to sign over here. Why? Because 1 is there. If 1 comes over here, and if there's an equal to sign, this doesn't match. Okay, so there's an equal to sign, so there will be y greater than or equal to 0, or minus y greater than minus 1. So whenever minus is there and you are changing the sign, so y less than 1. So that is y is greater than 0, so 0 less than or equal to y is less than 1. So y belongs to 0, 1. But look at the sign, okay, there's an equal to sign over here, so there's y, there's bracket and round bracket because there is no equal to sign. So that's for either greater than or equal to 0. That means that's for your positive one. Let me go with the negative one. Or y divided by 1 minus y less than or equal to 0. So that is, it will be y less than or equal to 0, or 1 minus y less than 0. Same thing over here also. There's an equal to sign over here. There is none. So it will be y less than or equal to 0, or minus y less than minus 1, y greater than 1. Now, if you look over here, it's given that y is less than 0, y is greater than 0. Do you think it's possible? No, right? So, which is not possible. So, hence, your range of your f of x. So, how much I got the range? That's the 1, so which will be nothing more than 0, 1. That's the answer. Okay, question 7 is given that let f, g such that r tends to r is defined respectively by f of x is equal to your x plus 1, g of x is equal to your 2x minus 3. Find f plus g, f minus g, and f divided by g. So let me just find f plus g, okay? So your f plus g, let me just give a x over here. So it will be your f of x plus g of x. So which is f of x how much? X plus 1 plus 2x minus 3. So if you calculate, you will get the answer to be nothing more than 3x minus 2. So that's all about your f plus g. Similarly, your f minus g of x would be f of x minus g of x. So which is x plus 1 minus 2x minus 3. Calculate it, you will get the answer to be minus x plus 4. And lastly, your f divided by g of x. So which would be your f of x divided by g of x. F of x happens to be how much? X plus 1 divided by 2x minus 3. Remember that whenever you put the value for x, the denominator shouldn't be 0. So which is the only number that your denominator will be 0? That's your 3 by 2, right? So comma, so x not equal to your 3 by 2, because if x happens to be 3 by 2, you'll get the denominator to be 0. So that's all about your question number 7. Question number 8 is given to be let f is equal to 1, 1, 2, 3, 0, minus 1, minus 1, minus 3 be a function from z to z defined by f of x is equal to ax plus b. For some integers a, b, I have to find the answer of a, b. Okay, so let me just make this one to be your equation number 1. Okay, so whenever you can take any of the element inside the curly bracket, I'll just take the first one. So whenever 1, 1 belongs to f, so according to definition of function, it will be f of 1 is equal to 1. That means f of domain is equal to your range. But according to equation number 1 is given ax plus b. In place of x, what I have? 1. So that will be a into 1 plus b is equal to 1. Let me just make equation number 2. As I said, you can take any of your elements. So let me just try to take the third element. Okay, again, so that now if I say, it will be again 0 comma minus 1 belongs to f, implies f of 0 is equal to minus 1. So similarly, from equation number 1, that will be how much? A into 0 plus b is equal to minus 1. So b will be equal to minus 1. So from equation 2, we have, so that will be how much? A plus b is equal to 1. A is equal to 1 minus b, that is 1 minus minus 1. So a is equal to 2. So I can say that therefore a is equal to 2 and b is equal to minus 1.